By using the measuring tape, measure the dimension of the disc and the axle by using the measurement tape, and then repeat the measurement and take the average result. Connect the hanger with the thread. Unlock the locking pin at the side of the apparatus and make sure it is in the tangential position. Next, measure the end of the hanger and it is its initial height. Make the reference line at the mark located at the pin side. The reference line will be used to recording the number of turns of the shaft. Hold the shaft with the locking pin to measure the distance for the three hanger. And then repeat the step for the second and third hanger. Record the data that you have in this table. Calculate the angular velocity for the hanger and assume one revolution take 1 second. Hi, my name is Alex Helson and Anthony from MEC 291, class G 3B. So today I would like to present my D1 experiment, that is wheel and axle. And my name is Alex Helson and Anthony, and then this is the result that I get from the previous procedure that I done. So this is the table. As we see here, we can see the initial height is 960 600 and 300 for the initial height in millimeter, and for the final height it is, for the one revolution is 700, for two revolution is 500, and for the third revolution is 350. So, and then for the second hanger is 550, 350 and 200, and for the last hanger is 250, 190 millimeter. So as we can see here, at this final height we can see the number decreasing, right? So now we move to the distance travel. As we see, as at the distance travel for the one revolution, for the hanger one is 200, 400 for the two revolution, and then third revolution is 550, and then for the second hanger is 50, 250 and 400, and the last hanger is 50, 200 and 210 millimeter that have here. So as we see at the distance travel, we see the number is increases. Yeah, so it's mean that the distance, the longer the distance is, the more distance travel, like that. Okay, for the discussion, compare and discuss the result from the different type of shaft. Like I said before, as we see here, the final height and the distance travel are very different. At the final height we can see the pattern that is from the one revolution, second revolution and the third revolution, the number is decreased, and then for the distance travel the number is increases. So it's mean that the bigger the wheel, I see, the bigger the wheel, the bigger the distance will travel, as we see in here. Because for the hanger one I use the bigger wheel, and then for the second one is use the medium, and the last one is small what do you call it, diameter of the wheel. The three hanger have a different result based on the table data, because the diameter of the wheel, yes, the greater the diameter of the wheel, the less force that required involved, yes. and then the height start to decreases when the number of turn of revolution is increased, but the distance will increase. This is what just I said, just like what I explained before. And then for the next is give your comment or a suggestion at least 4 causes of errors that may affect the result of the experiment. For the first one is the eyes is not perpendicular to the ruler. This is happen when we are trying to reading the scale, and then our eye is not perpendicular to the ruler, and then external wind, and then the mass of the axle and the human error. So this 4 is the causes that maybe affect the result for this experiment. And then lastly is explain how the theories in this experiment give effects in some real life application together with the example. For me, for example, is a bike tires, as we see tires, cars tires, windmill, because of the distance travel. Why I'm saying because of the distance travel, just we see at this table, the bigger the size of the diameter of the wheel and the shaft that involve, the distance travel are very long. You see here at the result that we get, and then the larger the wheel, the larger distance we travel. That's it. That is from me. Thank you.